Hi everyone. Today we're going to evaluate limits by simplification of complex fractions. Let us see example 1. Evaluate this limit as x approaches 1. This is our function. 1 over x plus 1 minus 1 over 2 all over x minus 1. Note that if we substitute x equals 1, we will get 0 over 0. And we call this indeterminate form. That is why we're going to evaluate this using simplification of the complex fraction. We copy the problem down here. Note that in our numerator, it is a difference of two fractions, and in the denominator it is the polynomial x minus 1. Let us first simplify our numerator. We can use the butterfly method. So that will be 1 times 2 will be 2. Then this is difference, so we write minus. We multiply x plus 1 by 1. So that is x plus 1. All over, we multiply 2 by x plus 1. And this is the answer. All over the same denominator, x minus 1. Note that our denominator is a polynomial, but we can write this as a fraction with denominator 1. And with this, we can show our complex fraction to be a product of two fractions. So, the first fraction is our numerator times the inverse of our denominator. So, that is 1 all over x minus 1. Then we multiply numerator by numerator, denominator by denominator. So, we have like this. In the numerator is multiplied by 1. That means the same value of this expression will come. Let us now remove the grouping symbol. Because this is negative, we are changing the signs of the terms inside of the grouping symbol. So we have this 2, then minus x, then minus 1. All over, we put together all the factors in the denominator. Then we simplify the numerator. That means this 2 minus 1. And the numerator becomes negative x plus 1. We can see that there is no common value in our numerator and denominator. However, we can do small manipulations. Show our numerator to be negative 1 times the quantity x minus 1. We have now a common binomial in numerator and denominator, and that is the x minus 1. So we can cancel it out. And to simplify, we have now the limit of negative 1 all over 2 times x plus 1 as x approaches 1. And from here, we can now evaluate the limit. That means we substitute this value 1 to the x. So our expression becomes negative 1 all over 2 times the quantity 1 plus 1. In the denominator, the 1 plus 1 becomes 2. We multiply 2 by 2, that will be 4. So the fraction is negative 1 over 4. And we can simplify this to be negative of 1 over 4. Example 2. Evaluate the limit as x approaches negative 3. This is our complex fraction. 1 over x plus 2 plus 1 all over x plus 3. Note that if we substitute x equals negative 3, we will get 0 over 0. And this is indeterminate form. Again, we will evaluate this limit using simplification of the complex fraction. We copy our problem down here. Let us now observe our numerator. It is a sum of one fraction and the constant 1. All over the denominator, the binomial x plus 3. Let us simplify our numerator. This whole number 1 we can write as 1 over 1. Another fraction. So we can use the butterfly method. So it becomes 1 times 1 is 1. Then this is plus. We copy the plus here. Then x plus 2 times 1. That is x plus 2. All over the product of x plus 2 by 1. That is x plus 2. All over, we copy the binomial x plus 3. The denominator x plus 3, we can show this as a fraction with denominator 1. And then, let us simplify this complex fraction. It becomes a product of two fractions. The first fraction is this whole numerator times the inverse of our denominator. So 1 comes up all over the binomial x plus 3. So we multiply now numerator by numerator, denominator by denominator. In the numerator, one factor is 1. So basically, the answer is simply this expression. Now we simplify this expression by combining 1 by 2. 1 plus 2. So that will be x plus 3. All over, we just put together the two factors. It's here. So we write the limit as x approaches negative 3. Now we can see that there is common binomials in the numerator and denominator. That we can cancel it out. We write again our simplified form into 1 all over x plus 2. And from here, let us evaluate the limit. That means we substitute this negative 3 to this variable x. So we have 1 all over negative 3 plus 2. The denominator is simplified into negative 1, and 1 over negative 1 is negative 1. This is the answer.